So today we're still talking about the chemical reactions. Okay, still talking about the chemical reactions, but this one, we're going to. Okay. What? Still talking about the chemical reactions. But here we're going to talk about a little bit deeper. For example, we need to know how to predict the chemical reactions, especially when we talk about double displacement reactions. So this is generally what when we talk about double displacement reaction, we know we have AB and combined with CD, and then they're going for AD and plus CB, right? So we know those are the two cations, they are replaced the positions. But we did not do the practice to how do we predict to write down the correct formulas. Okay, so for example, we do have sodium chloride. Let's just write something. Sodium sulfate and plus silver nitrate. So those are aqueous solution, which means they're dissolving the water. They're in the solution, they dissolve in the water. Those are all soluble. So this is double displacement reaction because we see ionic compound, another ionic compound. So the cations will exchange. So those two will replace the positions. But the point is, when we write this, are we going to write like a Na2NO3 plus AgSO4? Just let you know, no. Because those two looks like is right, but those two are not exactly the correct formulas. Yes, we have a sodium and combined with nitrate, silver combined with sulfate, but this is not exactly the correct formulas. You can go ahead looking at what is the common ion sheet. Go ahead. What is the charge for the nitrate? What is the charge for the sulfate? Last time we talked about the polyatomic ion. There are 4 of the very common polyatomic ion. I hope you can remember it. Nitrate, sulfate, PO4, and CO3. And the charge are separately, respectively, nitrate is -1, sulfate -2, phosphate -3, and carbon is -2. Those are a very common polyatomic ion that used. So that's why the reason you're going to be familiar with this is when you write the formulas, you will be able to directly write down what is correct formula. We know nitrate is -1, sodium is a +1 because it's 1A group, so they're going to lose 1 electrons. So +1 and +1, so we shouldn't have a 2 of sodium to combine to balance this, right? So the correct formula should be just NaNO3. And the silver, again, silver is also +1, nitrate is -2. So the formula will be silver 2SO4. So those two are correct formula, not the one on the top. Okay, so when you predict the correct formula, the major thing is you need to predict what is the correct formula for this. Okay, when you predict the correct product, you need to know how to write the correct formula. Okay, then you may think about, wait, if we're writing like this, it's not a balance. Of course, it's not balanced. Okay, then you're going to balance it. Okay, you're going to balance it. So, but first, you need to write the correct formula. And just let you know, if you're not writing the correct formula, that's going to be really hard to balance, or even that's impossible. Okay, so that is why we need to write the correct formula. So in this case, then you can say, okay, we just assume this guy is 2 because you see those sodium sulfate has multiple elements, right? And also 2, this is number 2 and number 4 here. So obviously I'm going to choose this one. So this is a 1, and we have a 2 sodium, right? 2 sodium. So right side we should have 2 sodium. 1 sulfate. So we should have 1 sulfate on the right side. And on the right side we have 2 silver. So we should have a 2 silver over here. And we have a 2 nitrate, obvious 2 nitrate. So it's balanced. Okay. So the major thing is you need to write the correct formula. That is the correct formula. And one more thing is the number 2 and 1 over here, that is a coefficient. It's talking about how many number of those formulas, how many numbers of those molecules. Okay. So those 2 and 1 is not belong to the formula. Just let you know. Okay. It's not belong to the formula. Okay. And also when you count the molar mass of this compound, do not count the 2, do not count the 1. Okay. The molar mass is this. The molar mass is this, not with the numbers in the outside. Any questions? Amber? Eliza? No? Okay, so this is how you predict it. The major thing is predict the correct formulas. Okay, so now please go ahead to work on the following one. Okay, we have ammonium sulfate. This is a aqueous react with barium chloride. Aqueous. Go ahead to predict the reactions. And also this is a precipitation reaction, which means there's a 1 is insoluble. So please go ahead and mark which one is insoluble. And when you balance, when you write the formula for the ionic compound, and make sure the charge. Okay, so that's why you need to figure out which all of those cations and anions, what's the charge for those, and then when they combine together, what's the correct formula they're going to make. Also make sure cations always first, anion is later. there's a one is a precipitate. And then you can go to the solubility chart, find which one is precipitate. So that's why I give you the solubility chart. Okay, so let's review it. Ammonia, barium, chloride, sulfate. If you're looking at over here, actually, you know the sulfate is -2 charge. Based on the balance over here, even you don't know what is the ammonia's charge, you can based on the formula, you know ammonia is +1 because we have 2 of ammonia to balance the sulfate. So ammonia is +1, barium is +2, chloride is -1. Looking at here, okay? So now if you know the balance, then obviously we know ammonia is going to combine with chloride. You see, ammonia is go combine with chloride. So now ammonia is +1, chloride is also is -1. So +1 -1, boom, combine together. Don't have to have any more. Just one of the ammonia ion and one of the chloride ion. That's it. Right? So the charge, you need to make sure the charge and then the charge is balanced. Okay, for then the compound will be neutral, right? And also the barium will combine with sulfate. Barium is +2, sulfate is -2. Again, those two +2, -2, we just need one barium, one sulfate, then boom, combine together. That's it. So now this is the correct formula: barium sulfate, ammonia chloride. Okay, and then you need to balance this equation to make this correct. Well, we just write a 1 over here. So we have 2 ammonia on the left, then we should have a 2 ammonia on the right side. Okay, yeah. Now we have a 1 sulfate, then we should have a 1 sulfate on the right side. And here it shows we have a 2 chloride, 1 barium. So obviously this one is 1 over here. So equation is balanced. To be honest, just to let you know, double displacement reaction, if you write the equation, the formula correct, is very, very easy to be balanced. Okay, very, very easy to be balanced. And if you're looking at here, the solubility, last time we just mentioned ammonia plus any of the anion will be soluble. Doesn't matter what kind of anion. Ammonia plus any of the anion will be soluble. Soluble means this is dissolving the water, which is aqueous. That means soluble. And barium sulfate is insoluble. This is a precipitate. So you write S over here. Last time I already mentioned S is not means soluble. S means it's a solid. So this guy is a solid out of the water. So that's a precipitate. Okay, that's a precipitate. So this is generally how we predict the reactions. Again, I will assign the homework for you to work on the similar questions. Predict what is the predict the double displacement reactions and figure out what is the result. Yes.
Why did you like the
We talk about, okay, so if you're looking at the solubility chart, you can also do so. Okay, yeah, the chloride and ammonia is in any other cation, then that's soluble. Or if you're looking at the ammonia in the third row, you see the third row, ammonia plus any of the anion, those are equal to soluble. Okay, yeah, so ammonia doesn't matter. It's ammonia sulfate, ammonia hydroxide, ammonia nitrate, ammonia carbonate, and ammonia plus any of the anion will always soluble. Okay, yeah. Yes.
On the right side of the equation, does it matter whether you put the
Doesn't matter. Doesn't matter. It really doesn't matter what kind. This is just to give your what's the product it is. I mean, doesn't matter you put a barium sulfate or ammonium chloride. I mean, doesn't matter which one you put it first.
Okay.
Okay, yeah. All right, so this is talking about the predict the reactions. And then we're going to talk about the net ionic equation. Today's lecture will taking a little bit longer. Okay. Net ionic equation. So I will talk about what exactly is net ionic equations. Okay, just like what we, okay, so let's just make one example like a previous here is sodium. We have sodium sulfate plus the silver nitrate. And then they are going to form sodium nitrate and plus silver sulfate. This is what we talked about in the previous equation. 1, 2, 1, 2. Okay, so this is the equations, chemical equation, and we generally call this is a chemical equations. Because those are all chemicals, right? We write over here are all chemicals or compounds. So that's why we call it chemical equations. But the point is, scientists try to figure out what exactly happening in these reactions. Are all the compounds, the ions, working in this reaction? Actually, it's not. So what they do? This is what we need to recall. We talk about electrolytes. Okay, so what is the electrolytes? You still remember?
What's the ion?
Electrolytes is the one that is an ionic compound that can dissolve in the water, right? Yeah, and electrolytes, most the case electrolytes, they are going to, one is electrolytes, the very important parts, which is electrolytes different from non-electrolytes, is when they dissolve in the water, they're going to dissociate, become ions over here. Okay, they are not going to have the molecules exist in the compound. Instead, they become ions. So that is why the dissolution, everything disappeared. Right? I mean, when you dissolve things, everything disappeared because they all become ions. So ions are very small. Your eyes cannot see it. So that's why it's disappeared. But when they combine together, the structure or the matrix is big enough so you can see it. Okay, so that is why this guy is become ions. They have one sodium sulfate become 2 moles of the sodium ions and 1 moles of the sulfate. So that is what happened. Okay, they become ions. Silver nitrate is doing the same thing. We have 2 moles of the silver nitrate over here. Then they're going to become 2 moles of the silver ion and plus 2 moles of nitrate ions. Okay, so this is generally what happened over here. Okay, so when they dissolve in the water, they totally become ions. And if you're talking about sodium nitrate, it's doing the same thing because this is aqueous. Aqueous means it's soluble, it's dissolving in the water. So 2 moles of the sodium nitrate is also dissolving the water. Become 2 moles of sodium ions and 2 moles of the nitrate ions. Okay, so this is generally what happened over here. They dissolve in the water and become ions. Okay, so based on this concept, but okay, the silver sulfate, then we're not going to do so because they say, remember, this is solids. In another word, it's a non-electrolytes. If this guy is a non-electrolytes, then they're not going to transfer electricity. So when they and they're not going to dissolve in the water. Since it's not dissolving in the water, then we're not going to having silver ion and a sulfate ion in the solution. Does it make sense? Does it make sense, right? So this guy is not going to making ions, no ion, because this guy is not dissolving in the water. So based on this concept, then scientist is going to just replace this stuff, replace the compound with those ions. This is what happens, right? They can replace the sodium sulfate with this, with the silver nitrate with this, replace the sodium nitrate with this. This is what happened. Okay, so now let's just rewrite the previous parts. 1 mole of the sodium sulfate become 2 moles of the sodium ions plus sulfate plus now 2 moles of the silver nitrate become this. 2 moles of the silver ions plus 2 moles of nitrate ions. Again, that is why I recommend you remember those charge for each of the polyatomic ion, right? The very common polyatomic ion, because you can, you can write those charge very straightforward. Okay. So now this is what we have in the reactant, right? Then we can write what we have for the product. The product, then they have 2 moles of the sodium ions plus 2 moles of the nitrate ion, and then plus again the silver sulfate, and this is solid. Again, you may ask why I am not going to write the separate the silver sulfate. Again, this guy is a solid, it's a precipitate. If it's a precipitate, then this is not electrolytes. We're not going to split this into ions. Only the one that's a soluble, which is an aqueous phase, can write those ions. Okay, can write those ions. So this is what happened in the solution. If you rewrite everything from the previous equation, this is what we have. And we call this is a complete ionic equation. Complete ionic equation. Okay, the reason it's called complete because we rewrite everything from the chemical compounds to the ionic, to ions. Then this is all complete. Only write the one that you can split. This guy is cannot, so we're not going to rewrite this. All right, so now this is called the complete. And where is the net ionic equation? This is complete ionic equation. So what does that mean? Net ionic equation. So if you're looking at this equation, you will see on the both sides of this equation, there are some common ions. Okay, there are some common ions. For example, you see 2 moles of the sodium ions, 2 moles of sodium ions, 2 moles of the nitrate ions, and 2 moles of the nitrate ions. Are you clear? Right? So those are common ions that shows in the equation. So those are common. And also when we learn the math, if you have the equation, both sides has the same thing, what do? You cancel it, right? You cancel it. So this is the same thing for the complete ionic equation. You just cancel it. In another word, this guy is not really do anything in these reactions. They are not doing anything. Those ions, they're just randomly go around. So that's why we call those ions called a spectator ion. So here we have 2 moles sodium ions and 2 moles of the nitrate ions. That's called a spectator ion. What does spectator mean? Just watch. You just watch. Just do nothing, right? Yeah. So in China, usually the spectator guy, we talk about, I mean, they're eating the watermelon and just watch. Okay, so that's a spectator. In US, probably just drinking the beer and just watch. Okay, yeah. So the same thing. The spectator, they are doing nothing. It just watch. Just watch what happening. Okay, so they observe the whole process doing, but they doing nothing. So that's why we can cancel those spectator ion. Okay, yeah. So then if you cancel those spectator ion, what is the leftover? The leftover will be just the sulfate ions, combine 2 of the silver ions, then they are going to form silver sulfate, and you have a precipitate. You see, this is what is exactly happening in the reactions. Precipitate is just one compound, right? One ionic compound. So the really is just this kind of cations and another anions combined together, making these solids out. Okay. For the rest of other ions like a sodium and a nitrate, they didn't do anything. Okay, so this is what we call the net ionic equation. Okay, this is what we call the net ionic equation. Okay, so the really net ionic equation is talking about what exactly doing in these reactions. Okay, it's just the one that can make a precipitate. Those cation and anion that can make the precipitate get together, make the precipitate. That's it. So this is called net ionic equations. Net ionic equation. Okay, yeah. So let's looking our study guide, the yellow study guide. Again, there's a lot of the practice of there. Hopefully you're working some of those. Yeah. I will try to make some of the answer key for you to do the practice. Oh, and by the way, today we're going to finish the lab 20. No, not lab 98. And tomorrow, next time, the Wednesday, we're not going to do the lab. Instead, we will do the practice over here. Okay, yeah, it's a time to do the catch-up practice. Okay, so let's turn to the page 15. Okay, page 15. Yeah, so today's lecture will be a little bit longer. Okay, 15. Here we have a lead nitrate. React with 2 moles of the potassium chloride, then making a lead chloride, and this is a solid, and 2 moles of the potassium nitrate. This reaction is not balanced, completely balanced. So this is what we have, okay? And then again, they want us to write the complete ionic equations. Complete ionic equation, then we need to split the one that shows is aqueous. In other words, is soluble in the solutions. So the soluble means this guy can dissociate the cations and anions in the solutions. So this guy is soluble. Lead nitrate is soluble. So in the solution, it's become a lead ions and 2 moles of the nitrate ions. You see, 1 lead and 2 moles of nitrate. And for the 2 moles of potassium chloride, it's doing same thing. 2 moles of potassium chloride will dissociate the 2 moles of the sodium ion and also 2 moles of chloride ions. So generally, this is what we have in the reactant. And then they're going to form the product. Again, we talk about this guy is a solid phase. In another word, this is insoluble, which is a precipitate. So since this is guy cannot dissolve in the water, so we will write it as it is, because this guy is not dissolving in the water, so no more lead ions and no more chloride ions in the solution. They're just combined together, making a lead chloride. And then for the potassium nitrate, since this guy is soluble, so they have 2 potassium ions and also 2 of the nitrate ions. Okay, so this is what we call the complete ionic equation. Okay, so go ahead based on the complete ionic equation and find out which one is the spectator ions, and then go ahead and write what is the net ionic equations. And spectator ion is the one that has a common, shows the same thing, exactly the same on both sides. Okay, so now you look at here. This equation already shows, and don't forget to write the charge because those are ions. Okay, it's not elements. If you write just like a PB, and then don't write anything, then that's elements. Until you write the 2+ over here, then that's a charge. This is a lead ion. Okay, instead of a lead elements. So in chemistry, sign is very important. Okay, if you change a little bit, it's completely different things. Okay, so now if you see the common things exactly the same, I see 2 of the potassium ion is exactly the same, and 2 of the nitrate ion over here is exactly the same. So those 2 can be canceled out. Can be canceled. The leftover is just the Pb2+ combined with 2 of the chloride ion to make a PbCl2 sulfide. Okay, so this is the net ion equation, and you recognize I'm not sure whether you recognize or not, the charge, total charge before and after the reaction, that's going to be also balanced. You see, we have a 2 positive, and then we also has a 2 negative. Then overall, 2 positive, 2 negative, making 0. And so that's why in the final, also no charge, 0 charge. So the net ion equation, the charge is balanced. The elements is also balanced. You see 1 Pb, 1 Pb, 2 Cl, 2 Cl. Okay, so charge and those chemicals are all balanced. So let's looking at one more, the second one. Here we have a fluorine. This one is more confusing. Okay, I just give you one example. This is F2. F2, it means fluorine gases, which is a diatomic gases, like a O2, like a hydrogen, H2. Okay, so this is diatomic elements. Then they have a strontium chloride. And then they're making strontium fluoride. And then the chlorine gases. Okay, yeah. So now let's see which are those things that can be rewrite as the ions. We talk about the one that is electrolyzed, which means they are ionic compound and they dissolve in the water, right? So is the fluorine ionic compound? No. So this guy is not electrolyzed. So don't split this. Chlorine gases is not electrolyzed. So don't split this. Okay. The only thing that you can split is just a strontium chloride and strontium fluoride. There's a metal plus non-metal. So this is ionic. And here it so shows AQ means it's dissolving the water. So that is why when you rewrite this, fluorine will keep as it is. It's just fluorine gases. And then they're going to rewrite strontium chloride. You see, strontium chloride have a strontium ions. Strontium is in the 2A group over here. Strontium, 2A group. 2A group, they're missing 2 electrons. So they are having 2 positive charge. Talk about the charge equal to their group number. So strontium 2A group is 2 positive charge. Just like a magnesium, barium, calcium, those are the same thing. Okay. First, let's see, is it balanced? Yes, I think that's balanced. Okay, then we're going to add in again. Here we have a chlorine. A lot of people write a Cl2 minus over here. This is not what we see, right? Are we writing the chlorine has a 2 over there? No. The 2 balance here means we have a 2 of the chloride ion that are binding with the strontium ions. So the correct formula is writing the chlorine ions, and then you put a 2 over there. This 2 means we have a 2 of the chlorine ion. And then they're going to strontium ions and plus 2 of the fluoride ion and plus chlorine gases. Okay, so now this is a complete ion equation. Go ahead to find what is the net ion equation and the spectator ion. And just let you know, chemistry symbol is very important. You're adding or taking off some stuff. It means completely different. All right, so let's looking at those questions. I know this one is confusing. I saw a lot of students, they say, oh, this one is the same thing canceled. This one, same thing canceled. This one, same thing canceled. Then they say, what? Everything is canceled, nothing left. I mean, how come we have nothing left? I mean, ionic equation, you're gonna have the equation, right? If you cancel everything, then what's the left over? Nothing. So that means that something cannot be canceled over here, right? Something cannot be canceled. That's because, again, I'm talking about here is the meaning of those are completely different. For example, F2 and 2F means different things. Why? F2, if you're talking about if this is a single fluorine molecules, if this is a single fluorine molecules, what does that mean? F2. F2 means this guy is a molecule that made by two of the fluorine gases. So the whole things combined together, making a F2. The two. So that's why you put the 2 over here. And this 2 means is belong to the one molecule. Okay. So this one molecule containing 2 of the fluorine atoms. And the 2F means what? Means that this guy is separately 2 of the fluorine molecules, not the molecule. Each of this also has a negative charge. So again, do you think that this one and this one is the same? It's not the same. This guy has 2 of the fluorine ions that in the solution. So you see, those 2 are different things. So that is why you cannot cancel those 2. These are 2 different things. The same, just like this, 2 chloride ion and different from one of the chlorine gases. So, and by the way, this is gas phase, this is aqueous. Aqueous means they dissolve in the water, right? So obviously, those 2 are different. So that is why you cannot cancel. Really things that you can cancel is over here. Because on the left side is strontium 2+ ion. On the right side is still strontium 2+ ion. So those 2 can be canceled. So that is why the leftover over here is just the fluorine gases plus 2 of the chloride ions to form 2 of the fluorine gases and the plus fluorine gases. That's it. You see, I have a 2 negative charge on the beginning, after 2 negative charge after that, and the elements also the same. Okay, so this is how we balance these equations. And sorry, I probably need to delay this class. I need to talk about one more things. Okay, yeah, one more things before we go to the lab. Okay, the next part we're going to talk about is the oxidation number. This is called talk about the redox reactions. Last time we talked about the redox reaction is something the redox oxidation number. If the oxidation number increase, then that's the oxidation. Or something is oxidized. If the oxidation number decrease, that means this is a reduction. Or something is reduced. Okay, oxidized reduction. This is generally last time what we talked. And we talk about one of the example, the copper oxide, copper 2 oxide react with hydrogen gases, and then they're going to form copper solids and plus water, liquid, okay, or gases, water gases. Okay, and we assign the numbers. We talk about all the elements. The oxidation number are all 0. Doesn't matter what kind of elements, as long as it's elements, it's all 0. And we talk about hydrogen is always +1. Oxygen is always -2, except the peroxide. Okay, so those are not peroxide. So oxygen -2, and copper. For those metals in the ionic compound, the anion in the ionic compound, they always equal to their charge. The copper 2 oxide, the copper is a 2 positive charge, so the oxidation number is 2. Okay, and then we talk about, okay, so something is got decrease, right? The copper is decrease from +2 to 0. So this guy is reduced. It's got a reduction. So the copper actually is reduced. Copper oxide is reduced. And you're looking at here, oxygen didn't do anything. Oxygen is still -2, but hydrogen is increased from 0 to +1. So this guy, hydrogen, is oxidized. So in this case, we can see copper oxide is reduced, and hydrogen is oxidized. And the reduction and oxidation is always coupled. Okay, something got reduced, something have to be oxidized. Okay, those two are coupled together. So generally, this is what we talk about. So now we're going to just re-emphasize how to recognize those oxidation, how to find oxidation number. How to find the oxidation numbers. So again, we talk about elements. They always is 0. It really doesn't matter what kind, like a H2. The 0 means each of the hydrogen atoms are 0. Each of the hydrogen atom, not the sum is 0. It's everything is at 0. O2 is the same thing, everything is 0, but copper is just copper elements as 0. Or you talk about gold, it's also 0. Doesn't matter what kind of elements, as long as the elements is 0. And the next one, oxygen. Oxygen is -2. Oxygen in compound, not the in elements. Oxygen elements is also 0, but oxygen in the compound is always -2, except peroxide. The peroxide is writing like this. This is peroxide. So for the peroxide, it's a -1 for each oxygen. But I'm not going to write the peroxide for you, so you can just remember oxygen is -2. Okay, yeah. And the hydrogen over here, let's just say hydrogen, there are sometimes could be -1, but I'm not going to write like this. So you just remember hydrogen is +1. Okay, hydrogen is +1 in most of the cases. So this is
In a compound.
in compound, yeah. Last one is ions. Ions in compound. Ion in compound, the oxidation number is just equal to charge. For example, copper oxide, the copper is a +2 over here, right? And we talk about sodium chloride. Sodium ion over here is +1, and chloride ion is -1. So the this guy, the oxidation number is just +1, -1. Magnesium oxide, magnesium is +2, so that's just +2. Okay, and if you're talking about a copper 1 oxide, this is copper 1 oxide, which means only each of copper is +1 over here. The oxidation number copper, this one is 1, and the oxygen is -2. Okay, so the copper, the elements, and those are in the ionic compound is just equal to their charge. What is the charge for these metals or anions? Then that's going to be just equal to their oxidation number. Okay, so those are the rules. It just give you a general rules, but it's not cover everything. A lot of the elements you still cannot see. For example, give you a very typical cases. You see, those are compounds only just made hydrogen, chlorine, and oxygens. Okay, but those are completely different things, right? We talk about those are all acid. Hydrochloric acid. This is called hypochlorous acid, and this is a chlorous acid, and this is called chloric acid. This is a perchloric acid. So anyway, those are all acids with hydrogen, chlorine, and oxygen. Okay, but the oxidation number for each of the chlorine is completely different. Okay, but the point is, how can we figure out the oxidation number for each of chlorine? Then we just need to, based on this rule, the sum of oxidation number is equal to 0. The sum of the oxidation number is equal to 0. Okay, the sum of the oxidation number is equal to 0, which means the plus the oxidation number within there, it should be summed together, which means, you see, the first one, hydrogen, we know is a +1. And then if you don't know what is oxidation number for chlorine, then you know the sum of that should be equal to 0, which means a +1 plus the oxidation number of chlorine should be equal to 0. And then 1 plus something equal to 0. So obviously chlorine is a -1, right? So that's why this guy is oxidation number is -1. The same thing shows up here. We know the oxidation number for hydrogen is +1. Oxygen is -1. And what is this? So +1 plus oxidation number of the chlorine plus -2 should be equal to 0. Then 1 plus something -2 equal to 0. Then chlorine should be +1. Make sense, right? Yeah. So this is again, so the chlorine is a +1. So the oxidation number for this guy, for this chlorine is +1. Same thing for here. 1, we know this one is a +1 and oxygen is -2. And once again, here we talk about oxygen is -2. It's not talk about 2 of the oxygen is -2. It's talk about each of the oxygen is a -2. So totally, this is a -4 for the oxygen. That makes sense? Are you clear? Okay. So now 1 hydrogen plus chlorine and plus 2 times -2. Then that should be equal to 0. So that means 1 plus something -4 equal to 0. So chlorine here is a +3. Right? 1 plus 3 minus 4 equal to 0. So chlorine here is +3. Then you can do the same thing, right? Go ahead to calculate those two. What is the oxidation number for chlorine? right? This one is +1. This is still -2. So 1 plus something -6, right? -2 times 3 is -6. 1 plus something -6 equal to 0. So this one should be +5, right? And this is +1, and this is -2. So 1 plus something -8 equal to 0. So this guy is +7. That makes sense, right? So you see, the oxidation number could change for the same elements if they are in the different compound. The oxidation number is different. The higher number means they have a higher willing to be reduced, right? Because they're really high, they try to decrease their numbers, so they try to reduce. Okay, the number has a very low, so they have a chance to oxidize. Okay, so now let's just review. Okay, remember last time at the beginning we talked about I have one case. Did I mention that? I have a mistake when I clean my toilet, right? So what I do, I put the works and the bleach, right? Works usually containing quite a lot of HCl, and the bleach actually containing sodium hypochlorite. Okay, so it's a similar like what we shows over here. So if you have works react with sodium, this guy, and then they're going to form sodium chloride and chlorine gases, and also they're going to form some water. Okay, so this is what happened. I did not balance this, but just like I mean, this one is not that easy balance. So you assign the oxidation number. You see the hydrogen is +1. We know this one is -1. Sodium ions, we know what is charge. That's a +1 because it's 1A group, right? So this guy is +1. This is a -2. So we can still figure out this guy is +1. Okay. And sodium is +1, chlorine is -1. This is 0. This is +1. This is -2. So you will see, is the hydrogen changing oxidation number? No, right? This is only one hydrogen is +1. This is also hydrogen is also +1. So hydrogen didn't change anything. The chlorine here, some of this, just to let you know, this chlorine is -1. This is still -1. But some of this, we have a multiple of this. Some of this is increase. From some of this is increase from -1 to 0. From -1 to 0. So that's why this guy is oxidized. And sodium didn't do anything. Sodium +1 is still +1, so didn't do anything. This chlorine gases from +1, they decrease to this guy from +1 to 0, and this is got reduced. Okay, oxygen didn't do anything. So that is why, see, some of this guy oxidized, some of this guy is reduced, and then they generate the chlorine gases. And chlorine gases is not pleasant, it's toxic, actually, it's corrosive. Okay, so that is why do not add works and bleach altogether. Okay, this is bad, really, really bad. Okay, yeah, so this is generally is oxidation redox reactions. Again, for the redox reaction, I don't expect you to write down or balance the redox reaction. I want you to first, you know how to assign the oxidation number, which means I gave you a formula, and you can based on the given formula numbers to figure out the oxidation number for some other elements. Okay, so this is the first one. Second one is you can recognize, give your chemical equation, you can recognize which one are oxidation number, which one is a redox reaction. That's it. Are you clear? Yeah, I will assign some of the questions in the homework about the redox reaction, assign oxidation number, predict the chemical reactions and the net ion equations in the coming homework. Okay, so let's pack things and we will go to the lab.